So the first question, this is question 4. You are given the exponential function f of x. Right? It's f of x power to a third to the power of x. Right? Before you do the question, you need to be aware that the base here is between 0 and 1. That's why it's a decreasing function. Okay, so let's start, write down the domain. Now, the domain of this function is starting to the far left, that's minus infinity, up to positive infinity. So your answer here will be x is an element of real numbers. Or you can write as minus infinity is less than x is less than positive infinity. You can also write it as x is an element, circular bracket, minus infinity to positive infinity. Any of those three. Right? Then write down the equation of the asymptote of f. What would be the equation?
Yeah, I also would write 0.
Do you remember? Okay, do you remember the day when I was talking about the equations of the x-axis, the equation of the y-axis, and I asked you to write it down? What did I say was the equation of the x-axis? I hope you are aware that the asymptote is the x-axis. What's the equation of the x-axis? I told you the other day many times. No, it's y equal to 0. It's not x equal to 0. It's the opposite of what you think.
I started out with x.
And then the y-axis
X equals to 0.
Okay, look here. Do you know that all horizontal lines, when you write their equations, it starts with a y?
Yeah.
Okay? So your x-axis is a horizontal line. Right? The value of y here, the value of y here at the origin, it's equal to what? To 0. So this straight line passes through. If I give you a line like this, and I say x is 2 there, sorry, y is 2 there, what would be the equation of that line? Could be what? Listen, if I give you a horizontal line like that, passing through a point where y is 2, if I ask you what's the equation of this straight line? No.
It's y.
It's y equal to 2. Any horizontal line, yes, when you write its equation, it starts with y. If it's a vertical line, it starts with x. So here, the equation of the x of the y-axis is x equal to 0. Please, this is very easy. You have to know this. Okay? If I give you, like, if I give you a straight line, sorry, no, I broke the door. The door is not opening, so I have to spin out. Yeah. Okay, if I give you a horizontal line, you know what? Your grade 9 teachers taught you this problem. If you have a horizontal line like that, if x is 3 here, if I ask you what is the equation of that line,
X equals to 3.
it's x equal to 3. Okay?
Yeah.
So any horizontal line, its equation starts with 1. Any vertical line starts with x. Okay?
You didn't know that, sir.
All right.
No.
Okay, so here, your answer for 4.2, it will be y equal to 0. Okay, it's very easy. Then write down the equation of, now here you don't have to pretend to do a workout, you just write the answer. Alright? But I don't want to do that. I would encourage you to go through the what? The procedure so that you don't make a mistake. So if if f of x is equal to a third to the power of x, what this means is that our equation we write as y equal to a third to the power of x. Then we swap x and what? And y, we get x equal to, or say we interchange x and y. When you get to this point, can you look on the board, please? When you get to this point, the base of the exponential is the base of the logarithm. This y here, which is the exponent, that's the logarithm. This x here is the number that you are going to find its logarithm. So when you write this, it will be y equal to the logarithm to base of a third of what? X. So if you write it in terms of function notation, your answer for 4.3, it will be f of minus 1 of x is equal to the logarithm to base of a third of x.
Sorry, why don't they tell me when to write the logarithm? What?
Can you come again?
Don't they tell you from the first
No. They just, you see this question here. It just says write down the equation of f minus 1 in the form y equal. So we can just write the y equal to the log to base of a third of
So I'm
x.
asking for the logarithm. They didn't tell us to write it, so
No, it's the inverse of the exponential. The inverse of an exponential function is a logarithmic function. You should know that by now. So for this question, you are not supposed to give your answer in exponential, in function notation. It's supposed to be like that. So let me write it. Write it again. That's right. Y equal to the log of x to the base of the third. This is your answer. So if you just write it, you get 2 marks because they said write down here. But I would encourage you to just do a working out to avoid making what? Mistakes. But you must know from now on that the inverse of an exponential is logarithmic. The inverse of a logarithmic function is exponential. Are you following? Because I don't want anyone, when you see a question with a logarithmic function and you're asked to find the inverse, then you say, but Mr. Chiponda didn't teach us this. The inverse of a logarithmic function is the exponential. You don't have to get confused. Okay? Yes, it must not increase. You should be smiling because I've done a number of examples now. Like 4.4 is the sketch now. To sketch it, it's a sketch, remember? Right? The base here, it's between 0 and 1. So it's a decreasing what? Function. And its asymptote will be the y-axis. So it starts from the top, it has got an x-intercept with x equal to 1, then it goes down like that. So when you sketch it for 4.4, you must get something like this. Obviously here, x is 1. So when you sketch it, you just draw it nicely, and then it goes. And then you label it. Okay? This will be y equal to the log of x to the base of a third. And then you are done. So it's 3 marks. One of the marks is for the x-intercept. The other mark for the shape, and you might get a mark for the asymptote. Are you following that? And your equation of your asymptote, as I said in the past, is x equal to 0. The equation of the x-axis is y equal to 0. But in this case, the x-axis is not an asymptote, it is the y-axis. Because we are talking about the inverse of the exponential.
Yes, exactly.
Okay, I will do that tomorrow.
Okay.
Yes.
What's one other point that we were looking for?
Okay, well, if you want to put another point, it means you can choose. You can choose, it's up to you. 1 mm, when it says one other point, means you can say maybe x is a half. What is the value of y? Okay, let me show you the calculator then. Well, this is the calculator. Okay, so you must have your log, right? So we put a third. Now you must have a calculator with the fraction option. This one here, because it helps. So I'll put a third. Okay, and then I said let x be a half, which is 0.5, right? Then I'll get that 0.6 what? 63. Now let's say if I had calibrated my x-axis with x being equal to 1 there, so y being equal to 1 here, and here I've got a half. It means by approximation, right, q problem is somewhere there, right, by approximation. So you just add the point there, and you say here x is a half, y is 0.63. 0.63 is very close to 2 over 3. So you just approximate. You can just put any point that you want. As long as that point is along the graph. Please, there is no specific group as to which point you are supposed to hit. That's your choice. Yes, you can have your point here, you can have it there, you can have it there, as long as the x value and its corresponding y value are correct. Alright? So that's 4.4. Then 4.5 now. It's an application of your knowledge of functions from grade 10 and last year, especially grade 11. So it says write down the equation of the asymptote of the inverse. Okay? When x is replaced by x plus 2. So what's happening is that this x here, we are going to replace it by x plus 2. And we get a new function. Okay? So let's move on to the next page. So 4.5. So our function or our inverse is f of x equal to the logarithm of x to a base of a third. Right? Now, f of minus 1 of x plus 2. Right? Now, I hope, okay, I'm going to ask you this. In terms of horizontal shift, what does this mean?
It shifted 2 units to the right.
2 units to the right or to the left?
To the right.
If you've got a binomial in brackets like this constant here, 2, it represents horizontal shift. Okay? The logarithmic function can be moved to the left or to the right. So the question is based on your understanding from grade 11, what does that plus 2 mean? To the left or to the right?
To the right.
No. To the right. It's the opposite of what you think. Right? So this means log base of a third of x plus 2. So what this means is that the y-axis is no longer the asymptote. The y-axis is no longer the asymptote. Okay? The asymptote moved 2 units to the left. So I'm sure we sketched it here. Right? So what that means that if we are moving this graph by 2 units to the left, okay, it means the asymptote also moved 2 units to the what? To the left. So we will end up having something like this. We are going to have here x equal to minus 1, x equal to minus 2. So the new asymptote is going to be there. It's going to be, its equation is going to be x equal to minus 2.
So it's going to be making negative 1.
Oh, well, sorry. Look here. Every point, including the y-axis is more like the y-axis is moving 2 units to the left. Remember, this is your asymptote before the horizontal shift. So if you move, and here please, you are not, okay, I want you to be aware that this part is a little bit confusing. Okay, I've never spoken about this, but maybe I just need to mention this. Do you know that when it comes to shifting of graph, you can shift the graph itself whilst the x and y axis are stationary. Right? You can also shift the graph, okay, both the Cartesian plane itself and the graph itself. And you can also shift the x and y axis whilst the graph is stationary. Now the question now is, among those three options, which one are we talking about when we are talking about horizontal shift? It is the shift of the graph. Okay. It's the shift of the what? Of the graph. Okay. The Cartesian plane, listen, the Cartesian plane remains where it what? It remains where it is. Alright, now, okay, check this. This is the asymptote, right? The graph is approaching the asymptote. A point which is very, very close to the y-axis. Do you agree with me that it's going to move 2 units to the left? If it moves 2 units to the left, it's going to get close to what? It's going to get close to -2. Okay, stop laughing because this is very serious. Okay? A point which is close to the y-axis. If you move it by 2 units to the left, it will move 1 unit close to -1, a second unit close to what? -2, which means our asymptote will be at x equals to -2. Right? This point here, which is the x-intercept, okay, I'm going to do a calculation, but I want to prove to you that it's going to be a specific value. It moves 1 unit, then 2 units. So the x-intercept will end up being at what? -1. Are you following?
Yes.
For some of you are looking down. Right. So our new x-intercept will be at x equal to -1. But we can do a calculation to prove it. Right. So I'm just going to do a calculation. Please, I'm giving you more information here. Okay, because I'm a teacher. Okay. So for this graph here, the new asymptote will be x equal to -2. Okay? It will be x equal to -2. But I'm just going to do a calculation. How do I know that it's x equal to 2? Remember, for it to be x equal to 2, okay, it means that the value, if you look at it here, it means that x will never be -2. That's what it means. X will never be -2. But x will be a value which is close to what? To -2. So if we want to determine the equation, another way would be to say, right? Remember, at the asymptote, y becomes what? Y becomes what? Okay, well, okay, check this. If I want to solve for the x-intercept, I'll put x equal to what? To 0. So let's put x equal to 0. Here, we'll put y, so that we'll have y equal to log base of a third of 0 plus 2. And this gives us y equal to the logarithm base of a third of 2. Then let's bring our calculator. If you bring your calculator, this is what happens. So let's say log to base of 1 log of what? Of 2. So that would be 1 over 3, right, of what? Of 2. So we'll get minus 0.63. Okay? Minus 0.63. Now, this minus 0.63, that will be the value of y. Okay? Where x is what? Is 0. Right? Are you following that? Which means the y-intercept, is going to be at, okay, I'll write it down here. Now y minus 0.63. Now, where is minus 0.63? It's going to be somewhere, well, if I put minus 1 here, minus 0.63 will be somewhere there. Initially, the y-intercept was what? It was non-existent. Okay? Because we have an asymptote. Are you following that?
Yes.
So because of the asymptote, there was no what? Y-intercept. After the horizontal shift, this curve here, it shifts to the left as well of the y-axis. Therefore, it will end up having a y-intercept here. Let's find the x-intercept. To find the x-intercept, you put y equal to what? To 0. So, if you put y equal to 0, you get 0 equal to the logarithm base of a third of x plus 2. You want to solve for what? For x. Now here you don't need the calculator, right? You are just applying your knowledge of converting the logarithmic form to the exponential. So this 0 here is going to be our exponent, right? 1 over 3 is going to be our base, so we end up having 1 over 3 to the power of 0 is equal to x plus what? Plus 2. This gives us 1. We end up having a grade 8 equation. Take the 2 to the left, we get 1. And then we get x equal to minus 1. Right? This is now the new x-intercept after the horizontal shift. Now, this x-intercept, it is so important for this question because it tells us that the asymptote is going to be to the left of it. I'm going to repeat that, but I'll show you on the graph. This is the x-intercept. The y-axis is to the left of this point. Am I right? After the horizontal shift, the x-intercept will be here, which means the new vertical asymptote will be to the left of minus 1. Okay? And that point is going to be somewhere here, or rather it will be at x equal to minus 2. Alright? So I've given you so much of information. So for this question, our answer will be equal to x equal to negative 2. Alright? That's our answer. I've said lots of things here, which in future you might encounter when you're doing your own questions. Yes. Alright?